Hello students, welcome back to our YouTube channel Geeks for Geeks, GATE Computer Science and Data Science. So in this video, we are going to continue discussing LU decomposition. In the previous video, we have discussed what is the LU decomposition, how to find out an LU decomposition. We have discussed all of that. We were solving a question and in which we got a calculation mistake. So we'll start from right there. So what we have discussed, let's just give a quick overview of what we have discussed. We have said that any matrix A can be decomposed into LU decomposition, right, where this is my lower triangular matrix and this is my upper triangular matrix. So if I have a matrix A, I can decompose it into lower triangular and upper triangular. But before defining, first I have to define either diagonal entries of L I can take as 1 or diagonal entries of U I have to take as 1. Then I'll be able to find out LU decomposition. So if somebody asks me that any matrix A has unique LU decomposition, I'll say that no. If I'll take diagonal entries of L as 1, I'll get different LU decomposition, and if I'll take diagonal entries of U as 1, I'll get different LU decomposition. But if I'll take diagonal entries of L as 1 and non-unitary diagonal entries of U, right, diagonal entries of L as 1 I have fixed, then LU decomposition is unique. If I'll fixed that diagonal entries of U is 1, then LU decomposition is fixed. Otherwise, there can be multiple LU decomposition. Then we have said that either if I have a 2 cross 2 matrix, so I can find out LU decomposition by writing 1 1 0 and 0 1, and this is L21, and I'll multiply it with U11, U12 and U22. I'll multiply these values, I'll multiply this matrix, the right hand side matrix, and I'll be able to solve LU decomposition. But for 3 cross 3 matrix, I'll have number of variables. For 2 cross 2 matrix, I can multiply these two matrix and I can solve it. But let's suppose for a 3 cross 3 matrix, how many values I need to find out first? I'm fixing diagonal entries of L as 1, 0 0 0, L21, L31, L32. So that means 3 values here, and here I'll have U11, U12, U13, 0, U22, U23 and 0 0 U33. So that means 6 values here and 3 values here. In total we'll have 9 equations to solve. So it gets lengthy here, So what would I do? I'll use another method. And what method we have discussed? We have discussed this method. We have said that what would I do? I'll take a lower triangular matrix like this and diagonal entries of L as 1, and I am going to row reduce this matrix and make it a upper triangular matrix, and whatever operation I am using to row reduce it, I'll just add those operations here in lower triangular matrix. So I get lower and upper triangular matrix. Right, I got lower and upper triangular matrix. So we have only discussed when I have diagonal entries of L as 1 and diagonal entries of U as whatever entries it can have, right? There is no condition on diagonal entries of U. But for the same matrix, if I want to find out LU decomposition where diagonal entries of L are not 1, right? Diagonal entries of L are not 1, but diagonal entries of U are 1. Then how I am going to find out that? Diagonal entries of U as 1, upper triangular matrix. Then how I am going to find out that? So we'll see that in a minute, but before that we are going to solve that question in which we were getting a error, right? So what happened in this question? I was trying to solve this question, but I am getting a calculation mistake. And what is the calculation mistake here? So here I got 3x3, right? So which gives me x3 is equals to 2. x3 would be 2 here. That's the error. If I substitute x3 is equals to 2 here, minus 2 into 6, that would 12 plus 2 14, and x2 would become minus 7, and x1 would become if I'll substitute minus 2x2 minus 6x3, so 6 2s are 12, 13 14, and x2 would be minus 7, and you would substitute the values here, minus 7 plus 2 minus, so x1 would be 6. So this would be the answer. So this would be incorrect answer. That's why we are getting the calculation error. x12, x2, x16, x2 minus 7 and x3 would be 2 only. Now you can check that. अब check कर लेते हैं. 3 6 are 18, 18 minus 7 11, 11 minus 6 5, right? Correct है. Third one 6 minus 6 plus 14 20 minus 10 10, right? So like it help us to check the solution by putting it into the equation. Now one thing you can see here, what we have done, we have used the LU decomposition to solve system of linear equation. But once again I am telling you that you have to use only LU decomposition when they have asked in a question, and if you are able to solve without using LU decomposition, you have to solve it accordingly. You have to solve using your usual method, because LU decomposition method gets really lengthy. First you have to make L matrix, U matrix, and then you have to solve using this U matrix first, then L matrix first. So it's really get lengthy. So instead of doing that, you just try to form a solve directly, right? Now let's get back to our topic, in which we have to discuss, we have to find out a LU decomposition such that diagonal entries of U as 1 and the L matrix can have any entry on the diagonal, right? So what would I do? Because I know row reduced would give me upper triangular matrix, but when I only need a upper triangular matrix, but first non-zero entry I have to make it 1, so that I'll get a upper triangular matrix. So let's see how we are going to do that. First I'll make this 6 value 1, because in upper triangular matrix right now I need 1. So what would I do? R1 approaches to R1 by 6. So what would it become? 1, 6 3s are 18 and 1 by 2. 2, 12, 1, 4, 15, 3. Because we have divided here at a diagonal entry, we have divided by 6. I'll multiply here with 6. Because here I am dividing it with 6. Previously what I was doing, if you guys remember, previously I was only subtracting, right? So I was adding at this position 1 by 3, 2 by 3, 1 by 2. But now for diagonal entries, I assume that L has diagonal entries as 1, because I have divided it by 6 here. I'll multiply it with 6. No addition, no subtraction on diagonal entries. It would be simply multiplication and division, right? Now what would I do? Now I'll make these two terms 0. Everything else would be same, but the only difference, it would become at diagonal entries. So R2 tends to R2 minus 2R1, comma R3 tends to R3 minus 4R1. What would I get? I'll solve it here. 1 3 1 by 2, it would be 0. 2 3s are 6, it would be 6, and 2, it would be 0 again, and it would be 0 3 2, that would become 1, right? So 2 and 4 get subtracted, so I'll add 2 and 4. This though 2 and 4, this I have only done like what I have done previously. Now I have to make this 6 entry 1, right? I have to make this 6 entry 1. So what would be my next operation? Next operation would be R2 tends to R2 by 6. What would I get? 1 3 1 by 2, 0 1 0 0 3 1. Now because I have divided it by 6, I'll multiply here with 6, right? Now if I'll solve it further, I have to make this value 0. R3 tends to R3 minus 3R1. 1 3 1 by 2, 0 1 0 0 0 1. So I have subtracted here 3, और यहाँ पे it has already 1, so I do not need to multiply any number. यहाँ पे 1 ही रहेगा. I do not need to multiply it with any number. Now this is my L matrix, this is my L matrix, this is my U matrix, upper triangular matrix. Now you can check that by multiplying that, are you getting this LU decomposition as this matrix A as not? Let's multiply. So 6 3s are 18 and 6 into 1 by 2, that would give me 3. 2 6 2 and 2 3s are 6, 6 plus 6 12 and 2 into 1 by 2 gives me 1. 4. I'm just checking guys, you can simply multiply by yourself this L and U matrix. 4 3s are 12, 13 14 15, right? 4 into 1 by 2, that would be 2 plus 1 3. So this is my LU decomposition. So by row reducing a matrix, you can form any LU decomposition, either lower triangular entries as one, diagonal entries as one, or upper triangular entries as one. But for this upper triangular entries, diagonal entries as one, it would get a little lengthy to solve, right? So make sure karo, if it is required to convert it into an LU decomposition, and they haven't mentioned that either they want diagonal entries of L as 1 or U as 1, if you are solving it by yourself, you would take it diagonal entries of L as 1, because it has lesser work. Here I have to use 4 operations, 4 times it gets completed into, in the last video it gets completed into 2 steps, right? So I think this LU decomposition thing is clear. So let's solve one question that they have asked in GATE exam. Okay, so they have said that consider solving the system, right? Consider solving the system. This is a system given to me, x1 plus x2 minus 2x3, and they have said that using LU decomposition, find L32, U33 and x1. And L and U matrix looks like this, and they have given these options for L and U. Now guys, just think about it, just pause this video and think about it. You would take diagonal entries of L as 1 or diagonal entries of U as 1. See what they are saying, they are asking for U33, and you can see in the option none of the value of U33 as a 1 in the option. None of the values U33 as 1. So that means I'll take diagonal entries of L as 1. So that means lower triangular matrix would look like this one. And I told you that what would I do to form a upper triangular and lower triangular matrix. First, let's find out upper triangular matrix. x1, x2 minus 2, x3. 1, 1 minus 2. The other values are 1, 3 minus 1. 1 3 minus 1, and then we have here 2 1 minus 5. So this is my matrix. I have to form L and U matrix so that I can just tell the values of L32 to L32, U33 and x1, right? So L32, I'll row reduce it. Let's do that. Now let's solve it further. So what would happen here? What would I do? I'll solve it. R2 tends to R2 minus R1 and R3 tends to R3 minus 2R1. What would I get? I'll get it here 1 1 minus 2, 0, 3 minus 1 2, minus 1 plus 2, that would be 1. 2 minus 2 0, 1 minus 2 minus 1, and minus 5 minus 4, that would be minus 1. Just check the calculation, you guys as well. So 0 and 0 it become, so negative of 1 we have subtracted, I'll add 1, I'll add 2 here. Right, now I have to make this entry 0. So what would I do? R3 tends to R3 plus 1 by 2 R2. 1 1 minus 2, 0 2 1, 0 0, minus 1 plus 1 by 2, that would gives me minus 3 by 2. And this is my and this U matrix would become, I'll have here negative of 1 by 2. Let's multiply. Let's just check it once. I always check so that we do not have a error later on. Minus 2 plus 1, that would be minus 1, right? 2 and 2 minus 1 by 2 minus 1, 1, ठीक है, minus 4 minus 1 by 2 minus 3 by 2 minus 5. -4 -3/2. एक मैट्रिक्स ठीक लिखी है हमने, -5x3 2 1 -5 1 3 -1 1 1 -2. ठीक है, ठीक है. I have row reduced it. R2 minus R1 -1 -5 plus 4 gives me -1. ठीक है. अच्छा यहाँ पे गड़बड़ हो गई ना. दिस कैलकुलेशन इज एरर ना. व्हाट वुड हैपन, -1 + 1/2 दैट वुड गिव्स मी 1/2. अभी ठीक है. -1 + 1/2 गिव्स मी -1/2. अब ज़रा सॉल्व करेंगे तो हमको अब ठीक मिलेगा. I was just multiplying this last row with this one. -4 -1/2 -1/2 -5. Right, now it is correct. Now what values they have asked? They have asked L32 and U33. L32 is third row second column, -1/2. So L32 is -1/2. U33 is third row third column in upper triangular matrix, -1/2. So you can see that which option is true. Do I need to find out the value of x1? No, I do not need to find out value here for x1. So I can say directly the option A is correct, right? If there is one another option, let's suppose we have this option as well, this option, this is -1/2, then you have to check, because you do not know what would be the value of x1. Then you have to solve for x1. But right now it is not required that we'll solve for x1 value. Right, solving x1 is not required here, so that's why I do not solve it. If it is required, so it's up to you guys again, that you want to solve x1 for with using LU decomposition or using your simple row reduction. So it's completely up to you, because we have already row reduced. You can just solve directly using this instead of solving L matrix. Not with this one, because you have to row reduce this augmented matrix. Not with this one it would work, right? You have to solve the augmented matrix and you can find out a solution, or you can use the LU decomposition, which we have discussed in the last class. First we'll solve for L matrix, then, right, how we have solved using LU decomposition. I have said that you would write down LUX is equals to जो भी B है, so UX you would take as Y, so LY is equals to B. First you would find out Y, then you get y, you would substitute it here, ux equals to y. With the help of that you can find out the values of x, right? So it's up to you again how you want to solve, but here it is not required, so I am not solving, right? So now we have discussed all the methods that how to find out a LU decomposition. So this is one question. Just try this question by yourself. Just try this question by yourself and let me know the answer in the comment section. And E2 vector is nothing but 0 1 0. This is a standard vector. We'll discuss it later on when we are going to discuss vector space subspace. E2 is a standard vector, 0 1 0. Even if I have to take 1 1 0, E3 0 0 1 for a 3 cross 1 vector, 3 cross 1 order. Right, so just try it by yourself and let me know the answer in the chat section. Now let's try to form a LU decomposition here. Let's try to find out LU decomposition for this matrix, and I'm just asking you for the simple LU decomposition. I'm just saying that find out an LU decomposition whose diagonal entry is of L as 1. Right, so that means you have to just row reduce it. So I'll do R2 tends to R2 minus 2R1 and R3 tends to R3 minus R1. I'll get the row reduced matrix 1 2 3 0 0 2 3s are 6, so it would become 3 minus 6, 5 minus 6, that would be minus 1, and this would become 3 minus 2 1, 4 minus 3, that would be 1. Now, so that means here I'll have 2, here I'll have 1. Now the question arises that how I am going to row reduce this 0. Now some of you would say that ma'am, row interchange R2 with R3, but I do not know what would happen with L matrix if I'll interchange row 2 with row 3. So that's why for this kind of matrices, LU decomposition does not exist. LU decomposition does not exist. But now the question arises that how do you decide every time that LU decomposition does not exist or you have made an error? Right, this is a question, that how would I decide that LU decomposition exists or LU decomposition does not exist? So for that we have this method. Do matrices always have an LU decomposition? No, sometimes it is impossible to write a matrix in the lower triangular and upper triangular, lower triangular and upper triangular matrix. So why not? Then, or they are asking that when the matrix would have all the LU decomposition. Why matrix would have, which matrix would have LU decomposition? How would I decide that? So let's consider a matrix A. What would the matrix I have? Let's suppose I have any matrix. What would I do? Let's suppose it is a 3 cross 3 matrix. So everybody knows what is a principal minor. Principal minor is, let's suppose we have A1, A2, A3, A4, A5, A6, A7, A8, A9. So when I say that principal minor, so first we will solve with D1. D1 is 1 cross 1, which is on main diagonal A1. D2 is A1, A2, A4, A5, this 2 cross 2 minor, and then D3, this 3 cross 3, A1, A2, A3, A4, A5, A6, A7, A8, A9. If all these leading minors have non-zero value, then we'll say that LU decomposition exists, otherwise LU decomposition does not exist. So they are saying the same. An invertible matrix A has an LU decomposition. All its leading sub-matrices have non-zero determinant. All its leading sub-matrices have non-zero determinant. So what problem I have faced in this question? So if I'll find out the determinant of this matrix, what would be the determinant? 1. So first I'll find out D1 minor, 1. That would gives me 1. D2 is 1, 2, 2, 4. So I'll get 0. So that is a problem here, that I got second leading minor as 0. But I'll check D3 as well, because it is not required ki if it is an invertible matrix, it would always have LU decomposition. Invertible matrix which has all the leading determinants, leading minors values always non-zero, then it would have a LU decomposition. And if I'll find out this determinant, 1, 2, 3, 2, 4, 5, 1, 3, 4. Let's try to find out this determinant. 4 4s are 16 minus 15 minus 2, 8 minus 5 and plus 3, 6 minus 4. So if I'll solve 1 minus 6 and plus 6, I'll get the determinant as 1. So it is an invertible matrix. Determinant is non-zero, but LU decomposition does not exist. So LU decomposition only exists when all its leading minor determinant have, all leading submatrices have non-zero determinant, right? And but you would ask, ma'am, if I'll interchange the rows, somebody would say that, ma'am, I'll make a new matrix 1 2 3 1 3 4 2 4 5. Now I'll see that D1 is 1 in this case, D2 is 1, D3 is 1, right? All leading minors have values non-zero, so its LU decomposition exists, but these are not the same matrix. So I'll say that for this matrix LUP, LUP is LU, lower upper triangular, and P is for permutation, right? This matrix exists, LUP exists, because I have permuted this matrix first, and then I am able to find out the LU decomposition. So we always say that LUP of a matrix always exists, but LU decomposition only exists if all its leading minus value is non-zero, right? LU decomposition may or may not exist, but LU, so lower and upper triangular factorization, permutation factorization would always exist, right? So I hope this point is clear. Okay, let's see some points, and we are going to see some metrics. So we are going to decide here that which of the following matrices have LU decomposition. So everyone would decide by themselves. So A is a matrix. So if I'll say for A part, what is D1? D1 is 3, D2 has value 3 minus 2, 1. So it has LU decomposition. It has LU decomposition. A matrix has LU decomposition. But when I solve this B part, D1 is 0 and D2 is minus 3. It is 0. So first leading minor is 0. So it does not have LU decomposition. But if I'll try to form LUP decomposition, that would exist, because I'll make this matrix A dash. A dash would be 3, 2, 0, 1. I'll interchange the rows. Now its decomposition exists, right? So that is my LU permutation. Now I'll check for C. D1 is 1. D2 is 1 minus 2 minus 3, 6. That would be 0. Again, not exist. D3. You can solve for D3, right? So here LU decomposition does not exist in C part. So only A would have LU decomposition. A would have the LU decomposition. Now so we already have reordered the rows, so that reordered matrix has LU decomposition. I already have done in the same matrix. I am writing it again, that what would I do? I'll interchange the rows 2, 4, 5. No, I haven't done that. क्या ये हमने कर लिया है क्या? हाँ, we have interchanged R2 with R3. देखो, if you would interchange R1 with R2, let's suppose you try to form a matrix 2, 4, 5, 1, 2, 3, 1, 3, 4. If you are going to interchange R1 with R2, it is not gives you LU decomposition, because again your D2 is 0. 2 into 2 minus 4. Minus 1 into 4. It would D2 is 0. So what would you do? Instead of doing that, you would interchange R2 with R3, like I have done on the previous slide. 1, 2, 3, 1, 3, 4, 2, 4, 5. Now you would have all the leading minus non-zero, right? Now, so that's the same thing they have written here, in which I already told you, that any matrix A admits an LUP factorization if A is invertible, then it admits an LU factorization if and only if its all leading principal minors are non-zero. If A is singular matrix of rank K, then it admits an LU factorization if first K leading principal minors are non-zero. Now what would happen here? A is invertible. If A is invertible, so we have A is invertible. If A is invertible, then A has LU decomposition. LU decomposition if all leading minors are non-zero, right? But if A is not invertible, agar A invertible hai, then we have this condition. If A is not invertible, then A would have some rank. A is not invertible, then what would I do? A would have some rank. Let's say A has rank R. A has rank R. Then you would take all R cross, you would take till R leading minors, right? R leading minors, or they have said that K leading minors. So if then A has LU decomposition if R leading minors, लीडिंग प्रिंसिपल और लिख लेना यहाँ पे क्योंकि दे शुड बी प्रिंसिपल माइनर्स well minors are non-zero. So if somebody asks you that if the matrix is not invertible, then it has LU decomposition or not, so you would check that. We'll check one condition, then we are going to get the result. So may or may not be. You would not say that if A is not invertible, then it would not have a LU decomposition. It can have a LU decomposition if R leading principal minors are 0. Like if I'll check this matrix 1 2 3 2 5 1 0 0 0. This matrix has determinant 0. It is not invertible, rank 2, but it has two leading principals. First D1 is 1 and D2 is 1, right? So both are non-zero, so it would have LU decomposition, and you can try to find out by yourself, right? Both have LU decomposition. Okay, so yeah, that's all for this video. We have completed LU decomposition. In the next video, we are going to start our next topic, that is eigenvalue, eigenvector. That's all for this video, guys. Thank you for joining.